Every elementary and intermediate algebra book will talk about real numbers, and you need to know how to classify them. A natural number is a number like 1, 2, 3. Now 12 over 4 is a fraction, yes, but it can be simplified to equal 3. 187, 1 million, 1 billion, 1 trillion, square root of 25 is a natural number because it can be written as 5. So the way you recognize natural numbers, and some textbooks call them counting numbers, is that they are numbers that you can count. Think of it as that you've got a plate full of marbles, and you can count them. You couldn't count -3 marbles, you couldn't count 2/3 of a marble, and you couldn't count 0 marbles. So natural numbers are numbers that you can actually count. Whole numbers, you can see, are the same as natural numbers, but I've included the number 0. 0 is a whole number, in addition to 1, 2, 3, and 12 over 4. They're also whole numbers. Integers are whole numbers, and they're opposites. So, be 1, 2, 3, 0, 187, 1 million, 1 billion, 1 trillion. And they're opposites. So -1, -2, -3, negative radical 25, or the square root of 25, -12 over 4, which is equal to -3. So whole numbers and their opposites are considered integers. Then we have rational and irrational. I'm going to skip down to the irrational numbers and describe them first. And then I'm simply going to say that everything else is rational. So irrational numbers would be square root of 2, square root of 3, square root of 5, square root of 7, pi, actually the square root of 11, square root of 59. Those are all irrational numbers. Any prime number, if you take the square root of that number, it is going to be irrational. For example, the square root of 4 is not irrational because that's equal to 2. Because 2 times 2 is 4. So anyway, rational numbers would be everything else. 1, 2, 0, everything above. All the integers plus fractions. Now, -4.5 can be written as -4.5 or -9/2. That is rational. A fraction is a number over another number, as long as that denominator is not equal to 0. Now, let me actually skip to the next page. And now I've got a page of just rational versus irrational. So you can see that all the rational numbers, 12 over 4, when you divide 4 into 12, it equals 3. It terminates. It ends. -4.5, -4.5, or -9/2. It's a fraction. If you divide 2 into 9, it goes in 4.5 times. It terminates. 1 to 5 is equal to 1/8 if you reduce the fraction 1/25 thousandths. -1/3 does not terminate. This is called a repeating fraction, a repeating decimal, 0.3333. It goes on forever. I put a bar over the last digit. However, irrational numbers, if you were to write a decimal form, it would not be one that terminates, and it would not be one that repeats. It goes on forever with no pattern. So the square root of 2, and that's why I write approximately equal, 1.4142135. Okay, so what we really call it, when we look at the square root of 2, we call it 1.414. That's just kind of, or 1.4, and that's an abbreviation. The square root of 3, you might even call it 1.7. It's approximately equal to 1.7. Square root of 5, 2.2. Pi, 3.141592654. Pi is actually equal to the circumference divided by the diameter, and it is frequently simplified as 3.14. Here we have a handy-dandy little chart that describes all the different types of real numbers. We have natural numbers. These are the numbers that you count on a plate. 1, 2, the square root of 16, that's equal to 4. 0 is not a natural number. You cannot count it. But 0 and natural numbers equal the whole numbers. And the whole numbers will be 0, 1, 2, 8 over 4, which is equal to 2, the square root of 16, which is equal to 4. And then we have the opposite of whole numbers, negative 2, negative 6, negative 5, 1, 4, and those together are going to equal the integers. Integers would be whole numbers or counting numbers plus 0 and their opposites. And if we include the integers and non-integer fractions, negative 1/3, 0.05, which is equal to 5 over 100, and you can reduce that, and 9/5, which is 1 4/5, 1.8, that can be simplified, written different ways. Those numbers together equal the rational numbers. And remember, I told you a number is either rational or irrational, and these numbers are not alike. They have nothing to do with each other. You can say that a whole number consists of 0 and natural numbers. You can say that 0 is a whole number, 0 is an integer, 0 is a rational number, 0 is a real number. But you can't say anything on these boxes to the left are irrational. However, irrational numbers and rational numbers consist of all real numbers. So anything on this page is going to be called a real number. What is not on this page that is not a real number is a number that is called imaginary or complex, and it looks like this. This is not real. And so most elementary algebra books and intermediate algebra books do not even discuss numbers that are not real. Whenever you're talking about anything, they'll say a real number that, or draw a graph of all real numbers such that, but they're all real numbers. This workforce product was funded by a grant awarded by the U.S. Department of Labor's Employment and Training Administration. The product was created by the grantee and does not necessarily reflect the official position of the U.S. Department of Labor. The Department of Labor makes no guarantees, warranties, or assurances of any kind, express or implied, with respect to such information, including any information on linked sites and including, but not limited to, accuracy of the information or its completeness, timeliness, usefulness, adequacy, continued availability, or ownership.